And now I'll hand off in a minute to Chuck. First, I just wanted to welcome everybody to the second day of AI meets CI workshop. Today we have a program that looks at AI tools for the major and mid-scale facilities data lifecycle. And Chuck will be talking first about a potential for AI throughout the data lifecycle. Then we have from Pete Beckman an example of using agents for science at the edge. Afterwards, we have a panel on AI in practice that looks at whatever tools and technologies that can be put into use throughout the data lifecycle. We have a talk from Trusted CI on exploring scientific security considerations in the age of AI, and then also lightning talks from the community. So welcome to the second day of AI Meets CI, and I'm passing on the baton to Chuck Vardeman, who's our very own CI Compass expert on everything AI. Welcome.
Thank you. So, as Ava said, today was meant to be a day where we could sort of start to talk about grounding the AI hype to some extent. And so what works, what doesn't, what sorts of tools are out there. So brief intro to me for the day, and this is the last I'll sort of say of that, but I'm a theoretical chemist by training who wandered into a cyber infrastructure center mainly because I built a lot of cyber infrastructure as a theoretical chemist and graduate student, and then wandered into how do we make our data AI accessible. And so I've been doing this for quite some time. This is now known as fair data. It's now known as knowledge graphs, now known as GraphRag, all of these sorts of technologies. I was part of several projects that are aimed at trusted AI, and that's where this beautiful little lifecycle, AI system lifecycle comes from. And a lot of that sort of knowledge that we gathered during the Trusted AI projects, I've sort of updated for software 3.0 versus software 2.0, which is basically neural network based systems. And we'll talk about that in a little bit of detail here in a second. But this is the tech report we've sort of posted in various places. It's on the registration page, and here's the DOI for it that Donna and I wrote. And that's where a lot of this comes from. Okay, so the obligatory, you're going to see AI-generated content. And I have purposely not edited that content very much. And I've done that for a very specific reason to show and prove some points. And I'll be pointing those things out as we go. But full disclosure, we used AI to do this. Okay. So in the tech report, I highly cite this paper from Mesrai and Crockett on illusions of understanding. And I think it's a really good framework to start from in terms of understanding generative AI and generative AI in a scientific process. And one of the issues with these models is that they're very good at giving the illusion that they can do X, Y, and Z, right? But unless you dive into it and interrogate it, it may not actually have done the thing that you thought it had done, right? And she classifies these in terms of a taxonomy, and some of that taxonomy is explanatory depth, illusion of breadth, and particularly the illusion of objectivity, right? And so I highly encourage everyone to go have a look at this paper because I think it's quite a fantastic paper. But the real reason that we're here, right, is quote unquote the imperative. So I already like how AI has basically hyped up what we're trying to talk about. But I would say that it's a goal, right? That the thing that we would like to do is shorten the time scale for novel and unique discoveries, right? And so that involves the scientific loop. We have, talked about yesterday in some fantastic presentations, various examples of using AI to enhance and shorten that scientific process. And in the paper, we go through, the tech report, we go through many, different examples of different parts of the observation, hypothesizing, simulating, comparing, all those sorts of processes and how AI might be used. So as a reminder, we haven't put up this slide yet, I don't believe, during the workshop, but CI Compass uses this data lifecycle as one of our core principles, right? And so I think virtually everyone that's here is familiar with the data lifecycle, but I did want to use this as an illustration. So this wonderful diagram was created by a colleague of mine at Notre Dame, Christina Davis, who is a PhD, postdoc scientist, now a visualization expert for the last 15 years in the center. But we can pass these things off to multimodal models, right? And so this is the AI generated version of the slide, right? And so you can see in this that it's very close, right? It's giving the illusion that it actually knows what it's talking about. But if you interrogate, say, data capture, does this actually make sense, right? In terms of what it's generated. At each step along the way, does it make sense? Now, there are also insights that can be drawn from this, right? And so sometimes you'll notice that in addition to an illusion, that there's a little bit of a nugget there that you might not have seen in the original diagram, some relationship, something. And so it's a sort of double-edged sword, to some extent, that these things, can give you the illusions of capability, but also at the same time may give you insights that you might not have seen. And the point that I want to make is that these models have their own knowledge representation of, and I put in quotes, reality, right? And that reality is essentially, trillions and trillions of tokens that are generated from, various sources that have been structured into parametric knowledge, right? And these are even worse now because they're multimodal, right? And so there's now this fusion between visual elements of the world and also textual token NLP-based elements of the world. And so they have their own sort of conceptualization, for lack of a better word. And in humans, when we're trying to come to some sort of a semantic agreement, that disagreement between a human on a particular concept, like what the definition might be, that's called conceptual drift. And I wanted to point out that the models have that same problem, that there is conceptual drift between the human and the AI. Okay, there are four archetypes that we are suggesting, at least four archetypes. I'm not suggesting that these are complete, but in looking at how facilities, particularly, we got some really good examples of that yesterday in the presentations of how AI embedded in the scientific workflows sort of can operate, right? And so there is augmented, which is sort of the AI's co-pilot. These can be chatbots. These can be AIs that are doing coding for you, etc. Automated, which is using workflows and infrastructure that may include AI, agentic, and explanatory. We also, like I said yesterday, I'm not going to spend a lot of time, had some really interesting examples of each of these sorts of archetypes within the major facilities workflow, right? And so there is one thing that I did want to clarify and spend a little bit of time on, and that is the archetypes of automated and agentic. And one might ask the question of, well, aren't they the same thing? And they're not. And so the automated archetype is really talking about AI in workflows where the control is programmatic in some sense, right? And so the decision making within that workflow or that loop, that computational loop, is generally controlled by some software 1.0, right? It is deterministic in some sense, right? AI may be a component of each of those things, right? So you may use AI to do anomaly detection. You may use AI to do X, Y, and Z, but that's part of a workflow and a flow. The agentic archetype is a little bit different in that the control of exiting the loop is essentially in the LLM's control. And so the LLM is trying to accomplish some set of tasks, usually using tools. And it exits the tool loop when it determines itself that it's accomplished the task. Whether or not it's accomplished the task is an entirely different set of concerns. And we will talk about that a little bit in terms of how do you go through and evaluate whether or not it's actually accomplished tasks. Okay, so this is obviously embedded throughout the life cycle. We saw that yesterday in all the wonderful talks I keep plugging on in terms of each of the flows of the workflow, including potentially automated, potentially using explanatory. So in terms of computational models that explain the data that you've seen. And also that, there is this interaction potentially between the human and the AI in that process of each of these steps, right? And it's cross-cutting. Okay, central principle though that we point out in the paper is that all of these things should strengthen human agency, right? We shouldn't necessarily be giving control without complete understanding of what we're giving to the AI, right? And so this is an important consideration that we talk about a lot in the paper.
Oh,
Um,
yeah.
whoops. Okay, so couple of other points. So what does open science mean in the age of AI, right? And I think this is an important concern. When I was a graduate student, my first job was working for OpenScience.org back in the late 90s. My advisor created this thing. When we started creating molecular dynamics software, we created it as open source because falsifiability requires, if you're doing science, the ability to falsify the computation, right? And so the ability to go and look at the code to see exactly what the model is and what the science that's coming out of that model corresponds to, right? And so I do worry about in an age of an AI, what does that mean? Even in particular, the explanatory models, how does that sort of fit in? I think this is still an issue. We also talk a little bit about this idea of layering, that the thing we sort of called an intelligence plane. And so the idea is that these archetypes, sort of sit in a layer, but underneath that layer is a whole bunch of things that make that AI work in a trusted and transparent and all of these sort of attributes that we have to do science. And so those generally follow in terms of either their fair principles, which we heard a lot about yesterday, data governance, which we're going to talk a little bit about today, and then the fact that this is all cyber infrastructure. And so all that cyber infrastructure has to have AI accessible testing, understandability, and everything else because AI is likely going to be helping us to build the cyber infrastructure going forward. And so these things need a consistent foundation. One thing I did want to point out is that this is evolving rapidly. And so I created a first set of these slides before Christmas. In between creating the first set of slides and today, there's already this idea of a context graph, which is exploding in social media. And they're identifying old problems. So a lot of the hype cycle that we see as people are trying these things, they're actually running into old problems that were known in other areas of AI and now are going, oh yeah, that's right. This is an issue, right? And so you can have your first $1 trillion opportunity. This venture capital firm is saying by recording the decision traces, right, and using a graph sort of method called a context graph to create observations and understand the decision process by which data or decisions within a company or whatever might have been arrived at. And so I'm going to point out that FAIR, especially the reuse part of FAIR, the R, that this was actually the purpose of this. It was the context graph, particularly using maybe something like Prov as a language for a graph language for recording that context graph. Because to reuse a scientific piece of code or data or whatever, you have to have that decision tree and those contexts around it to be fully understand how you can reuse it, right? And so these are older sort of principles that I think are important. I did also want to clarify one thing from yesterday from the FAIR guiding the FAIR discussions, in that it's worth reading through the actual paper. that define the fair guiding principles. And the fact that it was actually originally intended, and it came out of an AI community, a symbolic AI community, to talk about what we needed to do to enable agents to do e-science. And that the fact that this machine actionability, right, which we talked about yesterday during those wonderful presentations we had during the fair session, right, is that it provides affordances for agents, right, to be able to go and do things on your behalf. And they give a whole bunch of different examples that you can see here. But we're actually before where, this was originally published in 2015 or 2016, that there wasn't the capability of any agent actually going out and instantiating this sort of actions. And there are agents that now can do this quite readily. Okay, so the blueprints for trusted AI, we think fair, we think of governance, and we think that evaluations are important. We'll try to touch on some of those during the panel later on. We think that based off of review papers and the best evidence right now, that the sort of common sense approach is a good approach, that starting with small experiments, even vibe coding small experiments, investing in this sort of semantic backbone, and then using that to then leverage your way to more capable integration of AI within a particular infrastructure. We think that culture is important. Thank you for being here at our workshop today. We think that there needs to be a discussion between our end users and scientists and stewards of the data. We think that engineers and operators have a place in this, and we think that leadership also has a place in this. We talk about that in the paper. And then I'll leave you with one last sort of thought here, that we're moving toward a scientific infrastructure that is likely going to be dominated by either AI automated workflows or AI automated, self-deciding systems like agents or agentic patterns. And so for science, a human, and not just science, but in particular science, right, that we're moving toward this goal of that the human still has to be in the loop, right, and decide which steps matter, and that all of these things have to be transparent, verifiable, and hopefully enhance scientific understanding. That's the goal of all of these tools. So with that, I'll take a few questions if we have some time. I think we have 3 minutes?
Yes, you have 2 minutes. And if people, want to ask questions, raise your hand or put them in chat. Thank you. I see David has a question.
Yeah, hi, Chuck.
Hey.
Great presentation, thank you. I think the 4 archetypes is a great kind of model for thinking about how these things should be implemented. But my question is related to what I see as the potential for a kind of generational divide in young and up-and-coming researchers who are maybe going to start their careers with all of these tools available, and those who came before and are more used to doing things manually, hands-on, and have less of that maybe black box effect. Do you think there's going to be potentially issues introduced by younger researchers not really understanding how some of these things work fundamentally under the hood?
I do worry about this, and I'm not entirely certain how this is going to shake out, right? So one of the things that we see unfortunately happening in the software engineering world, right, is that we see a trend toward keeping more experienced programmers because they're better supervisors of the underlying agentic systems, right? And so in the panel that's coming up, I'm going to make some distinctions about types of knowledge. And so, experience and expertise is something that introductory people are gaining by that process of introduction, right? Now, I think there's that tension there that experienced scientists may not have time to go and understand all these things, right? And presumably, younger people may be willing to go and explore and play with these things, but you know, in my experience, most scientists are scientists because they're curious. And so if there's an opportunity and time, they're going to go experiment with the thing, right? Now they may not spend a lot of time experimenting with it because they have a lot of tensions and pull for their time. But generally speaking, I suspect that many of the folks that are attending this have at least gone and experimented to some extent with at least ChatGPT right now. I think education is a challenge, and we do need to think about, you know, how we start to introduce the tools to folks. But in my experiences, once you get them off of sort of the blank page problem, right? They understand the tool, what the capabilities of the tool are. They will go explore like once they get hooked on it, right? Um, so I guess the short answer, which I just turned into a long answer, is I'm not sure which of the two trajectories for science is likely to play out because I think there's a tension there. But I do worry about young investigators, and I think that AI is likely to have an impact on them, and it may be an outsized impact in some sense compared to older investigators.
Thank you.
Okay. Well, thank you. All right. So